Welcome, everyone. Thank you for joining us today. I'm Kelly Pirtle with NOAA Communications in Norman, Oklahoma, and a member of NOAA's Central Region Collaboration Team. I'm also your host for today's webinar. I'm very excited to kick off our 11th 3-minute thesis webinar and can't wait for you to hear from these speakers. Today's webinar is focused on drought. It's been another difficult year for many people, especially in the Western United States. The NOAA Central and West Regional Collaboration Teams have worked together to bring you the latest information about work on this topic. You can see we have a range of presentations from a NIDIS overview to drought monitoring and prediction to flash drought and mega drought, and even salmon recovery. Each of today's panelists will have 3 minutes and 1 slide to cover their topic. This format is based on a model used by universities across the country as a way to briefly share information about a project, initiative, or research. You can see from the outline, after each group, we will take a break for questions from you, our audience. And near the end of the hour, all of the panelists will return to respond to your questions for a few minutes. At any point during the presentations, please submit your questions in writing using the questions pane of the GoToWebinar panel, probably on the right of your screen. Asia Shumalo, the coordinator for the NOAA West Regional Collaboration Team, will be taking your questions and sharing them with our presenters. We're also being assisted today by Bethany Perry, the coordinator for the NOAA Central Region Collaboration Team. Good news is we are recording today's webinar, which will be available Monday, along with the presentation and relevant links to resources. These will all be on a web page for this event. We'll post this link to this web page in the chat near the end of today's webinar, and you will also receive it via email. We do these webinars every quarter, and I hope you'll join us in a few months for our next one covering winter weather. Seems appropriate for the winter, right? Finally, we'd love to get your feedback on this event. Please take a moment at the conclusion of today's webinar to complete a very brief survey. Okay, let's get started. For a webinar on drought, it is very appropriate to begin with an overview of NIDIS, the National Integrated Drought Information System. NIDIS was first authorized by Congress in 2006 and reauthorized in 2014 and 2019 with an interagency mandate to create a national drought early warning information system. NIDIS is a part of the NOAA Climate Program Office under NOAA Research. Viva de Heza has been the executive director since 2012 and is responsible for the implementation of the public law that authorized NIDIS. She supports agency congressional, legislative, and policy priorities to achieve the NIDIS mission, the goals, and the objectives. Since 2001, Viva's career has been dedicated to bridging the gap between governmental programs, scientific communities, water policy agencies, Congress, and the public to distribute essential information on water resources, conditions, and overall management. I'll now turn it over to Viva to get us started.
Thank you, Kelly. I'm excited to be here today with you all to tell you a little bit more about NIDIS. NIDIS is a multi-agency partnership that coordinates drought research, monitoring, forecasting, and planning at national, state, and local levels across the country. We do this in strong partnership with other agencies, organizations, and universities, and the private sector. Our mission is to maximize the nation's ability to proactively manage drought-related risks instead of being in a reactionary mode. NIDIS aims to provide the best available information and resources for people to assess the potential for drought and to better prepare for, mitigate, and respond to the impacts of drought. I'd like to highlight some of the best ways for you in the audience to receive that information or to become more actively engaged in NIDIS. First, we are working towards building a national drought early warning system, or what we call a DEWS, by taking a regional approach. So around the country are 8 regional drought early warning systems that address the needs of stakeholders, support rich networks of partners across the region, and integrate drought early warning across the economic sectors. You can become more actively involved by reaching out to your local regional drought early warning system coordinator and signing up for their email listserv to stay up to date on regional drought information resources and events. Second, NIDIS hosts the U.S. Drought Portal, or drought.gov. And in 2021, drought.gov served 1.25 million users who viewed over 3.45 million pages to get the latest drought conditions, outlooks, and impacts. Through the drought.gov, you can explore current and historical drought conditions, find drought maps and tools, sign up for local drought alerts, and learn more about drought and its impacts. Third, a unique product that comes from NIDIS and our partners are drought status updates. These regional updates communicate the current status of drought and its impacts across our regions and highlight potential areas of concern for drought development or expansion based on recent conditions and the NOAA forecast. We also produce a biweekly email newsletter, Dry Times, which has more than 4,000 subscribers. Dry Times provides a quick look at hot topics in drought, relevant resources, and also upcoming events. There are a couple of ways for you to stay in touch with all of the work that we do. We are on social media. Our Twitter account is particularly active with over 12,000 followers, and our Twitter impressions last year numbered almost 9 million. We encourage you and your program to retweet us in order to help us tell the story of drought across the nation. You can subscribe to our email list as well, which is where you will receive the Dry Times newsletter, regional drought status updates, as well as other highlights and upcoming events. If you go to drought.gov and find the button at the bottom of the page, you can subscribe. Thanks for your time. Kelly?
Thank you, Viva. That was a great start. Next, we're going to hear about drought research funding opportunities available through NOAA. Our next presenter is Molly Woloszyn, I know your name, I'm sorry, who serves as a Regional Drought Information Coordinator with NIDIS and is the program point of contact for both the Midwest and the Missouri River Basin Drought Early Warning Systems, also known as DEWS. Molly works with partners across her 2 regions to advance drought monitoring, forecasting, communication, planning, and research in the Midwest and Missouri River Basin. Take it away, Molly.
All right, thank you, Kelly. So today I'm going to highlight NOAA's approach to funding drought research, focusing on opportunities provided through NIDIS and the Climate Program Office. Drought is a very complex topic. Compared to other natural disasters, it is often a more slowly evolving event and affects a wider geographic area at different timescales. Interdisciplinary and applied research is crucial to begin to answer some of our toughest questions around the topic of drought, including how does drought impact ecosystems? What data should I use to monitor drought in my region? And how do you monitor and plan for drought under a changing climate? These questions and more are questions that NOAA and NIDIS are trying to answer through funded research projects with partners across the country. We provide drought research funding through a few different mechanisms. Since 2007, NIDIS has provided funding to more than 60 innovative drought research projects through the Coping with Drought Research Competition. Past Coping with Drought research projects have assessed the impacts of drought on agriculture, ecosystems, and water resources, and developed decision support tools for regional, state, and local use. The Coping with Drought competition is typically offered every 2 years, with successful FY22 projects focused on either ecological drought or building tribal drought resilience being announced soon. Specific themes may vary for each competition and are informed by the needs and emerging issues identified by a broad range of stakeholders across the United States. The Modeling, Analysis, Predictions, and Projections, or MAP program, is another competitive research program through the Climate Program Office. MAP supports research to advance our modeling, understanding, predictions, and projections of Earth's climate. Since 2011, NIDIS has partnered with MAP to support new research projects every 3 years that have resulted in new drought understanding, capabilities, and products. MAP also organizes the Drought Task Force to coordinate and amplify the activities of the U.S. drought research community. The Drought Task Force is a leading community of practice around drought research and development in the United States. Through our regional dues, NIDIS also supports the co-production of applied research at the state and regional level to address stakeholder needs. An important emphasis for NIDIS is ensuring research to action. Our goal is to ensure that federal research on drought is as coordinated and integrated into decision-making as possible, and to promote interaction between the research community and the beneficiaries of their research. Thank you, Kelly.
Thank you, Molly. Our next speaker will discuss a relatively new part of NIDIS. Dr. Crystal Stiles is the first Tribal Engagement Coordinator and has been with NIDIS for just over a year. Crystal is the key point of contact for tribal engagement, and she is working on building relationships with tribal partners and implementing the NIDIS Tribal Drought Engagement Strategy. Crystal has 16 years of experience working on drought issues and 8 years of experience with tribal engagement. Tell us more, Crystal.
Thank you, Kelly. At NIDIS, we highly value our relationships with our partners, and we wanted to make a stronger commitment to ensuring that our tribal partners are equal partners in responding to drought. So in 2019, NIDIS partnered with the Masters of the Environment program at the University of Colorado Boulder to develop a tribal engagement strategy. The strategy was developed based on input from tribal environmental and resource managers from the Missouri River Basin and Midwest regions, and contains 3 guiding principles of engagement, as well as numerous outcomes and proposed activities associated with those outcomes. Since the strategy was published in 2021, we have hit the ground running with implementing the strategy. One of the first things NIDIS did was hire a tribal engagement coordinator, that's me, to help build relationships with our tribal partners and facilitate these activities to implement the strategy. Perhaps one of our biggest activities thus far was holding a funding competition to build tribal drought resilience. After a rigorous review process, NIDIS selected 5 projects to be funded that will involve implementing strategies and activities outlined in previously existing tribal drought, water, or climate plans. The reason for this is because we heard directly from our tribal partners while developing the strategy that there are lots of funds for developing plans, but very little funding for implementing the actions in those plans. We felt that it was crucial that the tribe be involved from the very beginning of and throughout the project. So as part of the competition, we required that a tribal member lead or co-lead the project. These 2-year projects will be kicking off soon, and we are excited to see these projects through with our tribal partners. NIDIS has also been supporting tribes in the U.S. Northern Plains and Missouri Basin regions as they have contended with drought over the past few years. During last year's growing season, when drought had a stronghold in the Northern Plains, NIDIS partnered with several organizations to host and facilitate a tribal drought webinar series focused on recent conditions, outlooks, and impacts occurring specifically on tribal lands. Also, NIDIS is leading an effort to complete a drought assessment for the Northern Plains and Canadian prairies. We wanted to ensure that our tribal partners were involved and heard, so we collected impact information to put in the assessment, and we invited 2 of our tribal partners to be co-authors. To summarize, NIDIS has been very busy working with our tribal partners to increase drought resilience. In the coming year, we hope to continue to engage with them and expand our tribal resources on the U.S. drought portal, drought.gov, through listening sessions. That's a wrap. Thank you for listening.
Thank you, Crystal. Now we will take a few minutes to address some questions. You can type your questions in the questions pane of the GoToWebinar control panel. Asia?
Thanks, Kelly, and thanks to our panelists for your excellent presentations and helping us understand the role of NIDIS in working on drought. The first question I have is for Viva. What's the best way for people to connect with NIDIS if they're in one of the grayed out areas in the DEWS maps?
That's a great question. We typically refer to those polygons that represent the DEWS regions as having fuzzy boundaries, meaning that we don't constrict ourselves to just working with partners that are caught within the colored polygon. So we work across those regional boundaries, and often we do assist with early warning activities in other states. So probably the best way to get a hold of us or to connect with us is to contact the coordinator on drought.gov. If you click on a particular region, and I would suggest choosing one that perhaps is closest to your location or your state, and reach out to the coordinator that's working with that particular region, and then they can take it from there.
Awesome, thank you, Viva. The next question is for Molly. How can we know when funding opportunities are available?
Yeah, so a couple of ways that you can do that. First, any funding opportunities that we have or in partnership with anyone else would go out through our biweekly newsletter, Dry Times. So that's a great way to actively get the information. But we also would have that information available on drought.gov. We do have a funding opportunities page, and my guess is we would also do some sort of drought.gov news story and put it on social media to try to spread the word. So those are some of the best ways.
Thank you, Molly. Next question for Crystal. What's your advice for engaging with tribal nations in a meaningful and culturally appropriate way?
That's a great question. I think that for me, anyway, in my experience, really trying to leverage some of existing relationships with people who already have relationships with tribal partners has been a really great way to kind of get in the space and to get to know our tribal partners better in that way. And also just really trying to kind of read up on or do your research on, if it's a particular tribe that you're planning to work with, understanding their background situation or customs and such, and just making sure you're going into that that relationship with kind of a little bit of knowledge about what to expect, what cultural expectations there may be, and so forth. But yeah, anyone here that would like to talk about that more, be happy to talk with you about that. Thanks.
Thank you, Crystal. We have time for one or two more. This question is for Viva. Can you describe a bit more what exactly drought early warning means?
Yeah, that's a good question. I like getting this question. A lot of people have an idea of what early warning means, and it's often kind of grounded in when we think about hurricane or, more importantly, tornado early warning, where there are alarms around the community that go off and people run for their shelters. And in this particular situation, we're not talking about an actual alarm bell or a siren going off, but what we're really talking about is developing a solid set of drought indicators, whether they be atmospheric indicators, sometimes even drought impacts can serve to some extent as early warning indicators of what is shaping up and what's to come, as well as water indicators of drying conditions. And so by using those indicators, we can get a sense of what is shaping up to be a drought that's impending, and then we provide kind of our own version of an alarm by sending out information and alerts. We partner very closely in this situation with the weather forecast offices at the National Weather Service. They also issue statements, drought statements, to inform the public about what is shaping up in their region. So hopefully that sheds a little bit of light on what we mean when we talk about early warning regarding a very slow moving hazard such as drought.
Thank you so much, Viva, and thank you all for the great answers. And for time, I'm going to turn it back over to Kelly to move on to our next presenters. Thank you, guys.
Thank you, Asia and presenters. Remember, you can type your question in the questions pane of the GoToWebinar control panel. Our next speaker is a forecaster at the NOAA Climate Prediction Center in College Park, Maryland. Adam Hartman creates short-range temperature, precipitation, and hazards forecasts, long-range drought outlooks, and serves as a U.S. Drought Monitor author. Adam is also the Climate Prediction Center's GIS focal point and serves as a NOAA GIS administrator, helping to publish web services for various line offices across NOAA. Tell us about the U.S. Drought Monitor, Adam.
Thank you, Kelly, for that introduction, and thank you all for joining me here today to talk a little bit about the U.S. Drought Monitor. So As was alluded to, drought is a slow-moving climate phenomenon, and losses from it can be as substantial as those from other faster-moving natural disasters such as hurricanes, floods, wildfires, tornadoes, what have you. It can cause losses to agriculture, can affect domestic water supplies, energy production, even public health, just to name a few of its effects. But what is the Drought Monitor? So what the Drought Monitor does is provide weekly analyses and assessments of ongoing drought conditions across the U.S. and its territories. It is released every Thursday at 8:30 a.m. Eastern Time and valid for the week ending on the preceding Tuesday, so that Tuesday leading up to the Thursday release. The Drought Monitor is not a forecast. It looks backward at observations, not forward in time. Several national, state, local, and tribal governments and authorities use the Drought Monitor. The most notable example at the national level is the USDA, Department of Agriculture, using it to trigger drought disaster declarations. But in addition to that, at the lower levels, state and local decision makers use it to trigger drought responses. But that's typically done in combination with more local drought indicators, as drought can have very large variations, both spatially and temporally, and drought can have very different meanings depending on the region in which you live. The Drought Monitor is a multi-agency collaboration. Authors from the National Drought Mitigation Center, NOAA, and the U.S. Department of Agriculture are on a rotation, usually serving 2-week shifts at a time when producing weekly drought maps. Each week, the Drought Monitor author on duty collaborates with scientists and experts nationwide, consolidating and analyzing scientific data, expert input, even impact reports, and in doing so, provide a comprehensive convergence of evidence approach to provide a snapshot of drought intensity for that given week. Aside from the human contribution to the Drought Monitor, though, I would like to touch briefly on the technology behind it. As you can see in the workflow diagram on the right-hand side of your screen, much of the authoring process is performed using Geographic Information Systems or GIS software. The Drought Monitor is currently upgrading this software, which will not only streamline and facilitate the existing workflow, but also provide a future avenue for expert input from around the country to be ingested directly by the authors, with the end goal of increasing efficiency, improving accuracy with which weekly expert recommendations are addressed, and ultimately, hopefully, saving time. In closing, given the scale of human collaboration nationwide every week and the technology behind the process, the U.S. Drought Monitor is considered by many to be the gold standard of drought monitoring around the world, and we are continuing to look for ways to improve this product going forward. Thank you very much for your time, and I'll hand it back to you. Thank
you, Adam. Our next speaker is Dr. Krista Peters-Ladard, the Acting Director in the Sciences and Exploration Directorate of NASA, where she has been Deputy Director since November 2021. She has served in a variety of research and management positions with NASA for more than 20 years. Her research interests include land-atmosphere interactions, soil moisture measurement and modeling, and the application of high-performance computing and communications technologies in Earth system modeling, for which her Land Information System team was awarded a NASA Software of the Year award. Krista is coming to us from her vacation, and we very much appreciate that. Welcome, Krista.
Right, thanks, Kelly. All right, great to be here, and I'm thrilled to talk about indicators, information, and impact. So if we go to our next slide, the key points I want you to remember are here. But first, I want to define what is an indicator. So you saw previously that the Drought Monitor relies on inputs, and indicators are some of those inputs. They are variables that are used to describe drought, such as precipitation, temperature, stream flow, groundwater, snowpack, or soil moisture. And so as we think about indicators and the information contained within the indicators, I'd like you to focus on my first key takeaway, which is indicator importance varies by location. So if you look in the upper right of the graphic, you'll see two sets of bar charts. There's one for the West and one for the non-West US. And what we did was we conducted a study using information theory to rank the top 15 indicators for the West and the non-West using their contribution to the U.S. Drought Monitor as the ranking criteria. And what we found is that, you know, depending on the location, different indicators matter. For example, if you look at the West, you see indicators at the top like SPEI, which is a standardized precipitation evaporation index. There is things like the Palmer Index, but there's also something that doesn't appear in the non-West, which is GRACE, which is a groundwater indicator. So at the top of the non-West, you see a bunch of soil moisture as well as other variables like the Palmer. So that's the first takeaway, that depending on where you are, indicator importance varies. The second takeaway is that information content varies in time. And if you look at the lower left, you will see a series of 6 indicators. This was part of a study we published. And the bottom line is that this is the flash drought of 2012. And if you look at the time series and you see that line, which is the 20 percentile, that's the threshold for drought. And you can see that some indicators, like the evaporation indicators, indicated drought earlier than the other indicators. And the recovery, which is at the end of the drought, the soil moisture was the last to indicate recovery. The final point I want you to remember is that combining indicators improves drought information. The previous speaker talked about convergence of evidence. This on the lower right is a study, again, using information theory, where we looked at the cumulative information contribution from every indicator on this chart, again, relative to the drought monitor. And you can see that as you add more information, those bars go up, meaning that information is continuously being added. So the impact of each indicator matters, and as you add more information, you can see how that varies in time. And I'd like to end it there. Thank you.
All right, thank you, Krista. Our next presenter is Dr. Hailan Wang, a meteorologist specializing in drought monitoring and prediction at the NOAA Climate Prediction Center. She leads and performs research and development to improve CPC drought monitoring and prediction products. She also conducts climate research to study causes, mechanisms, predictability, and prediction of drought. Please explain more about what you do, Hailan.
Thank you, Kelly. So next, I'm just going to switch the gear to drought prediction. I'm going to talk about the drought outlook products at NOAA Climate Prediction Center, which is also called CPC. So these outlook products include our existing deterministic drought outlook, as shown on the left, and the new probabilistic drought outlook that CPC and NIDIS are currently developing, as shown on the right. So the operational deterministic drought outlook that CPC is currently producing include the seasonal and monthly drought outlooks. They're produced and released on a monthly basis and respectively provide the drought forecast information for the upcoming one season and 1 month. So to give you an idea of what the drought outlook look like, the top left is one example of the seasonal drought outlook. It shows the drought tendency information color-coded for 4 drought phase categories. Drought will persist, develop, improve, or be removed. The brown arrows on the bottom give you a brief idea on how the drought outlooks are produced. They're basically initialized using the latest US Drought Monitor, and the drought tendency information was produced by integrating a variety of information, including short-term forecasts, long-term forecasts, climatologies, and analogs, together with the feedback from local stakeholders. And the lower left panel gives you an idea. Here, just use the seasonal drought outlook as one example to show the product performance verified using the US Drought Monitor changes as observational reference. So the scale is in general good for all drought phases, with the only exception for drought development, as shown in the rightmost bar, just mainly because of the difficulty in predicting the precipitation deficit and heat waves that typically drive these drought developments. It is also worth noting that these existing deterministic drought outlooks are subjective, because they're produced by CPC drought forecasters based on their expert assessments. To address this, CPC plans to improve the products by making them more objective, such as automating the production and verification procedure. And recently, CPC and NIDIS started working on developing the new probabilistic drought outlooks, which, as you can tell, contain the probability information. They're also objective. So these new drought outlook products we're currently aiming to develop include the seasonal, monthly, and flash drought outlooks. And here on the top, on the bottom right, we provide a simple schematic to outline the production procedure. So all starts from the subseasonal to seasonal forecast, followed by applying the calibration and bias correction to improve the skill and reliability of the meteorological forecast. We then produce a forecast for land surface state by driving land surface models with post-processed meteorological forecasts. And after that, the forecast for various drought types, including meteorological, agricultural, and hydrological, will be produced. They're subsequently integrated using drought blending approach. And finally, we would apply social science to decide on the format of the final product. So this effort is going to take several years to materialize, and we'll be happy to keep everyone posted when the product's available. So I'm just going to stop here. Thank you. Back to you, Kelly.
Thank you, Hylon. It's now time for some questions. We appreciate those of you in our audience who have already submitted them. Do you have a question you want to ask? Type it in the questions panel of the GoToWebinar control panel. Asia?
Hi, everyone. So my first question is for Adam. Who can contribute and provide input to the weekly maps?
So that's kind of, I got some feedback.
Yeah.
It's kind of the beauty of the Drought Monitor. Anybody can contribute. So typically, Drought Monitor authors each week coordinate with state climatologists, regional water managers, people from WFOs to get information related to impact reports and some of the nuances that are going on in their state related to drought. But the layperson can go to the Drought Monitor website and submit what we call condition monitoring observer reports. They can take pictures, rate the situation in their location, compare it against past events, and that comes directly to the Drought Monitor author. We check those condition monitoring observer reports each week, and rely heavily on those too sometimes, as they also serve to corroborate a lot of times what we see in the data. So they're very important, and yeah, like I said, anybody can contribute, and it's been very helpful to have that capability.
That's awesome, and thanks for that, Adam. Our next question is for Krista. Noting the suite of indicators varies by region, is there one or two indicators that seem to have a larger importance regardless of geography?
Right. So based on our analysis, as you rank the indicators, there is, I would say, either the SPEI or the soil moisture tend to be persistently in the top, I would say, 5 most important indicators. I think the variability comes in with indicators like groundwater, and even snow comes up in certain regions as well. So, but yes, the top ones would be SPEI and soil moisture.
Thank you, Krista. And time for one or two more questions for Hylon. What is the Climate Prediction Center's near future plan to improve drought prediction products?
Yeah, that's a good question. I could say that our near future plan has 2 folds. Some of them are touched on in the presentation. On one hand side, we are going to develop this new probabilistic drought outlooks, which, as I mentioned, we're going to develop the probabilistic seasonal drought outlook, sub-seasonal drought outlook, which include the monthly drought outlook and flash drought outlook. This effort is going to take several years to complete because it involves substantial research and development. So at the same time, we plan to improve the existing deterministic drought outlook. And in order to do that, we plan to make the products more objective and less subjective. And this is going to be proceeding by developing an objective drought monitor or utilizing an existing objective drought monitor when available or appropriate to initialize the drought outlooks. And meanwhile, we are going to develop tools to automate the production and the verification procedure. So overall, the eventual goal is to make the probabilistic drought outlooks operational, but it's going to take several years to materialize. Before that happens, we're going to continue producing and improving our existing deterministic drought outlook to ensure smooth transition. Thanks.
Thanks, Hylon, and thanks to all of you. And I'd like to hand it back to Kelly to move on to our final set of presenters.
Thank you, Asia. We'll now transition to our final group. Our next speaker, Jason Otkin, will help us better understand the characteristics and impacts of drought. Jason is a research scientist at the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison. In 2011, he began working with colleagues at the U.S. Department of Agriculture and the University of Nebraska-Lincoln to explore a special type of drought known as flash drought that develops very quickly over a few weeks. The timing of this new research endeavor was auspicious because it coincided with a severe flash drought that impacted much of the central United States in 2012. He has since published numerous articles on the topic. He is a member of the NIDIS Flash Drought Technical Working Group and was a member of the Scientific Organizing Committee for the NIDIS Flash Drought Workshop in 2020. Jason?
Thank you so much, Kelly. It's a pleasure to be speaking with all of you today on a topic that is very near and dear to me. Because flash drought is a relatively new concept, many people have asked me, what are flash droughts and how are they different from regular droughts? The short answer is that flash droughts are a subset of all drought events that are distinguished by their rapid rate of intensification. So people usually think of drought as being a creeping phenomenon, something that may take many months to reach its peak intensity. But as we've seen across the United States in recent years, droughts can develop very quickly over only just a few weeks. Flash droughts are typically caused by a combination of extreme heat and below normal rainfall that lasts for at least a few weeks. So the simultaneous occurrence of multiple weather extremes and moisture stress during a flash drought can severely impact vegetation health. This is demonstrated in the figure on the left, which shows images from a phenocam located in north central Oklahoma. The top two panels show the vegetation before and after a flash drought in 2012, whereas the bottom two panels show the vegetation on the same dates in 2014, which is when weather conditions were more typical for the region. You can see in the upper left panel that the native grassland vegetation was relatively green on July 1st before the flash drought started, but that it had rapidly turned brown and had most likely gone into dormancy after several weeks of extreme heat and no rainfall. This rapid desiccation of the landscape during the flash drought stands in sharp contrast to the continued greenness of the vegetation that occurred over the same time period in 2014. So many tools have been developed in recent years to monitor drought conditions. One of the most widely used is the U.S. Drought Monitor. This is because it combines information from numerous data sets and impact reports in order to produce a weekly drought severity analysis. So the middle figure shows changes in the U.S. Drought Monitor over 4 and 8 week time periods for 3 high impact flash drought events that have occurred across the U.S. during the past decade. Now, locations that are shown in orange and brown on these images saw a 3 or 4 category increase in drought severity, which means that they went from being drought free to having extreme drought conditions in only a few weeks. This is very rapid drought development, and this is the hallmark of flash drought events. I'll end by saying that accurate monitoring and prediction capabilities are critical for flash drought because their rapid intensification presents unique problems for vulnerable stakeholders. So when drought develops so quickly, there's simply less time to prepare for it and to mitigate its impacts. It's also vital that more time is spent working with stakeholders in order to better understand how we can develop tools to better meet their needs. Various studies are underway to better understand and predict flash drought. And I'll also mention that NIDIS has recently formed a flash drought technical working group that is bringing together researchers working on flash drought. So I'll end here and I'll send it back to Kelly.
Thank you, Jason. Now I'd like to welcome Evan Bing Sawyer, a NOAA Fisheries Natural Resource Management Specialist who works to coordinate the response to drought conditions in the California Central Valley. Today, he will talk about the often contentious and litigious issue of California water and how drought has forced urgent action toward recovering the Sacramento River winter run Chinook salmon, which has been listed as endangered under the Endangered Species Act. Evan, tell us more.
Thanks, Kelly. In talking about California water, drought, and species recovery, I want to use a specific example of the endangered Sacramento River winter run Chinook salmon. This species, which is found at the extreme southern extent of Chinook salmon's range, is blocked from its historical spawning habitat by Shasta Dam, shown in the top left figure. Winter Run, which used to comprise 4 populations, is now limited to a single population at high risk of extinction. Really, being limited to a single population is the most significant source of concern regarding the status of the species overall. Also concerning is that the population is dependent on the release of cold water from Shasta Dam to provide suitable spawning conditions for the species. This is shown in the bottom left figures portraying temperature riverscapes and comparing wet versus drought conditions. So what happens when there is a drought, and what actions are taken to protect the species? One of the most significant effects of drought is the reduced volume of cold water in Shasta Reservoir, shown in the top second figure from the left. The lack of cold water constrains the ability to provide suitable spawning habitat, and during drought, the species is limited to a very short reach of the river. Ultimately, these conditions contribute to higher mortality and lower productivity that in turn limits the species' ability to replace itself and be self-sustaining. To mitigate these effects, NIMS is focused on both near and long-term actions to support species resilience. First, expanding the conservation hatchery production, and second, by taking steps to expand access to historical habitats above impassable barriers. Increased hatchery production is a near-term solution as it directly increases the number of offspring produced, but it has long-term consequences for species viability. The long-term solution is to reintroduce these species to their historical habitats. In response to the previous drought, spanning the years of 2013 to 2016, a jumpstart was given to the Battle Creek restoration and reintroduction effort, identified in the top second figure from the right. Since 2018, over 560,000 juvenile winter run Chinook salmon have been released into Battle Creek, and as recently as 2020, there have been documented cases of successful spawning and the natural production of juveniles. Fast forward to the current drought, when this year we've partnered with state and federal resource agencies, and importantly, the Winnemem-Wintu tribe to transport winter run eggs into the McCloud River above Shasta, where water temperatures are considerably cooler than below Shasta Dam, shown in the bottom second figure from the right. In this case, hatchery spawned winter run eggs were brought to a remote site incubator so that the eggs could incubate in the waters of the McCloud River. These are only initial steps towards reintroduction and ultimately recovering winter run Chinook, but I cannot stress enough how critical it has been for us to be able to partner with agencies and stakeholders. NIMS really couldn't do this on our own. In spite of drought, or maybe even because of it, we've been able to bring together a diverse group of partners to implement urgently needed recovery actions. Thanks.
Thank you, Evan. We're now going to move from a specific issue to the big picture in the West. Our final speaker, Dr. Andrew Hoyle, is a research meteorologist at the NOAA Physical Sciences Laboratory who focuses on the predictability, projections, and processes concerning regional hydroclimatic extremes. His research is used in forward-looking assessments of food and water security. Today, he will present on the processes and risk of compound precipitation and temperature extremes during the 20th century mega drought in the western United States, which together depleted water resources in this water-stressed region. Andy?
Thank you very much, Kelly. Before I begin, I'd like to acknowledge the journal article this study is based on, shown in the lower left-hand part of the slide, and that it was supported by the National Integrated Drought Information System, the NOAA Climate Program Office's MAP program, and NOAA's focus on the changes in western United States hydroclimate. The most intense 22-year drought in the western United States since the reign of Charlemagne in 800 AD was extended by compound dry and hot extremes in water year 2021, which spanned October 2020 to September 2021. Compared to an instrumental record that dates back to 1895, low precipitation and high temperatures were widespread across the western United States. The intense and prevalent drought caused widespread water delivery shortages, damaged ecosystems, and contributed to extreme wildfires. California and Nevada were once again at the epicenter of drought and heat in water year 2021. The scatter diagram on the left-hand part of the slide shows water year temperature standardized departures on the vertical axis and precipitation standardized departures on the horizontal axis, with the shading indicating the water year. Cool shading indicates water years dating back to 1895, and warm shading indicates water years as recent as 2021. Water year 2021 was the first time since 1895 that precipitation fell below -1.5 standardized departures, and temperatures exceeded 1.5 standardized departures concurrently for the California-Nevada two-state average. Two other important features to note from this scatter diagram are that temperatures have warmed in California, Nevada, and that no significant change in precipitation has been observed since 1895. Our study found that climate change in La Niña increased the risk of compound heat and dryness in California, Nevada in water year 2021. We used 4 climate model ensemble simulations to come to this conclusion. We use climate model ensembles because they provide many more realizations of the climate than are possible from our observed history. The climate models are to climate scientists as a laboratory is to a chemist. Focusing now on the 4 scatter diagrams of temperature and precipitation on the upper right-hand part of the slide, the 4 couple climate model ensembles indicate that anthropogenic effects principally caused an increase in extreme high temperature risks, while La Niña effects principally caused an increase in the extreme low precipitation risks. We separated years in which La Niña was active in a recent climate, shown in purple, from past years in which La Niña was not active, shown in gray, in the past climate, all of which indicates a shift to warmer and drier conditions in the former. Consistent with this, the climate model ensembles indicate a 6 to 12-fold increase in the compound risk of extreme high temperatures and extreme low precipitation like water year 2021. Note that the models differ in the magnitude of the relative risk because each model simulates the climate slightly differently. With that, I'll conclude. Thank you very much.
Thank you, Andy. Keep your camera on. It's now time for questions about these last 3 presentations. What questions do you have, Asia?
Thanks, Kelly. First question for Jason. Can flash drought happen without drought occurring? And if so, how predictable are such kinds of things as flash droughts?
No, one of the key things with flash drought is that it has to end in drought. You have to have drought impacts in order to have flash drought. So with flash drought, it really takes 2 steps. You have to have that period of rapid intensification, which can start in the absence of drought, but then it has to, at some point, reach drought conditions to be categorized as flash drought.
Great, thank you. Next question is for Evan. What other actions is NOAA Fisheries taking to address drought on the West Coast?
Yeah, thanks, Asia. So I think maybe 2 things come to mind, both of which sort of reinforce the need to work with our partners. First, we are working on, we're working with other federal agencies, federal and state agencies to reevaluate how water is stored and moved throughout the state. Ultimately, this will result in a ESA consultation between NOAA Fisheries and the Bureau of Reclamation, and where NOAA Fisheries will ultimately issue a biological opinion determining whether the Bureau's water operations would increase the extinction risk to NIMS trust resources. The other thing that I can think of is we've also used what's called, what we're calling the Voluntary Drought Initiative, and that's where NOAA Fisheries, the California Department of Fish and Wildlife, and the State Water Resource Control Board are working with water right holders to secure voluntary commitments to maintain flow in smaller streams and tributaries. This is more of a proactive approach to ensuring that minimum suitable conditions are protected for NIMS trust resources.
Awesome, thank you, Evan. Next question for Andy. What does your research suggest for the future of compound heat and dryness?
Well, the risks of heat are going up greatly in a warming climate, and compound heat itself is enough to win the day and carry the day, so that these years are much more likely. When it comes to precipitation changes in a changing climate are much more regionally focused, whereas the temperature effect is much more widespread. And because of that, the temperature effect is therefore going to increase these widespread increases in the compound risk.
Thank you for that, Andy. Next question for Jason. What tools are most useful for monitoring flash droughts?
That's an interesting question. My opinion is that it really takes a very large basket of tools and monitor metrics in order to properly monitor flash drought, because its impacts can really cascade through different aspects of the environment. So you might want to start with precipitation and temperature indices, but then that's ultimately going to lead into reduced soil moisture, reduced evapotranspiration, things like that. And that's also going to be dependent upon season, region. So it kind of gets back to what Krista was talking about, but perhaps with even more granularity, where it's going to really depend upon like the sector you're looking at. So it's a very complex problem that definitely needs to be looked at more closely.
Thank you, Jason. Next question for Evan. What are the next steps towards recovery for Sacramento River winter run Chinook?
Yeah, thanks again, Asia. So really, I think the next steps are to continue with the actions that have been taken, the urgent actions taken during drought. So that's a continuation of the Battle Creek reintroduction and McLeod reintroductions, but also to transition to the more developed reintroduction plans for those actions. Also, we need to protect the existing population below Shasta and Keswick dams, and working with partners to maintain suitable temperatures below Shasta. I guess I would also say that there's a need to address some emergent issues related to species recovery, like there's a thiamine deficiency issue that's come up. A lot of this is described in the species in the spotlight information that I shared with, that I think is included as a link to the meeting materials.
Thank you, Evan. And thank all of our presenters. We have time for more questions, so I'd like to welcome everyone back onto the screen right now, and we'll try to cycle back through some of the questions that came up through the audience over the last hour. And I'll start back with Crystal. What specific challenges do you see tribes facing in regard to drought that other communities might not experience?
Yeah, it's a great question. I think one would probably be access to resources, which is unfortunately true for a lot of other aspects of life and not just with drought or climate and so forth. And the way of life is very different. I'm sure, a lot of people are hearing more about this idea of indigenous knowledge or traditional ecological knowledge. And these are different knowledges from the Western science that many of us are so accustomed to. And I think the challenge, and we're starting to get the idea there, but starting to think about how those two sciences can come together and basically complement each other to come up with solutions for drought or climate change or other extreme events and such. That just adds that layer of complexity to it, but I think is actually a really good opportunity for us to take advantage of, to try and incorporate the ITEK more in the decision making and in drought as well.
Thank you, Crystal. Next question for Molly. Are there funding opportunities for graduate students about drought?
That is a great question. I would say, and I don't know, Viva, are you maybe more equipped to answer this one? I think that there definitely are graduate students that have worked on projects before that have been NIDIS funded through our competitions. But Viva, would you like to take that one?
Yeah, that's exactly the answer, Molly. It's very common that when teams are assembling to submit proposals to grant competitions, they more than often include graduate assistants as part of the research team, and then they're compensated through the grant funding. As far as targeting specifically graduate level researchers, no, we've never targeted a competition specifically to that, but they do appear quite often in the proposals.
Thank you both for that. And this might be a group answer kind of question as well. What kind of educational materials are available about drought? And a second question to that, are there any citizen or community science initiatives related to drought?
Yes,
I can take a stab at this if you want me to. Okay. All right. So many educational materials. It's important to note that a lot of what NIDIS focuses on is really, not that there's not other education materials for other audiences, but the real focus has been on materials to explain drought and what's happening around the country related to drought. And also equally important is the role that high precipitation events play in ameliorating or terminating drought. And so all of those materials can be found on drought.gov, and they come in the form of a multitude of things. I touched upon some of them, such as drought status reports. We often, when we are collaborating with partners or convening partners, much of the discussion and priorities that come out of those discussions are captured in reports. We support many researchers that put out great publications. And then we have a lot of documents, whether they be 2-pagers or multi-page documents, that tend to take strive to take the research and really bring it down to a level that's understandable and actionable. And then the other question that was asked about citizen science, so many citizen science opportunities that NOAA is a part of and is leading. One of the ones that NOAA has been really involved in for the last 20 years has been COCO-RAWS, which is the Rain, Hail, Snow Collaborative citizen science effort. And this data, the COCO-RAWS data that's collected by citizen scientists in the field, is used by the Drought Monitor authors, or at least it informs their weekly process to look at where drought is forming or where it's persisting. That's just one of many citizen science efforts that NOAA is a part of.
Thank you for both of those and for keeping up with my two-part question. This next question is for Adam and Krista. Are the drought monitor determinations built on different models in different regions, since the most important indicators seem to be different?
So I kind of alluded to this in my present. Sorry, I'll just quickly, you can follow up, I'm sure. So I kind of alluded to this in my presentation. Drought can have very different meanings depending on the region in which you live. So out west, for example, hydrologic indicators are very important. Stream flows, groundwater, reservoir levels, snowpack, even in runoff in the spring season, has a large effect on what drought may look like in western regions, western areas. Whereas maybe say in the Midwest, a lot of the impacts and indicators are more agriculturally focused. So what does the soil moisture look like? What does stream flows look like? Things of that nature. So yeah, there are various indicators that we may focus on depending on which region or location even in the country that we're looking at. So it does kind of get a little cloudy sometimes when trying to explain, you know, what drought looks like and why it is depicted in this very specific way for your particular area.
Okay. Yeah, so I think we're almost out of time, but our study basically is looking at it using information theory, and so we are analyzing individual drought regions as well as times of year. And so when that is published, you'll be able to learn more.
Thank you so much, Krista, and back to you, Kelly, since we're out of time.
Yes, thank you. Thank you all. This has been such an interesting and timely webinar. A big thanks to all of our wonderful panelists today, coordinators Bethany Perry and Asia Shumalo, as well as you, our audience. I hope you have learned something useful. You've asked lots of good questions, and if we didn't get to yours, we will pass it along to the panelists. As a reminder, the webinar recording, along with a number of great resources mentioned today, can be found at the webpage added to the chat box, and we will also email that to you. As we end, please stay on for one more minute to answer a few brief questions that will appear on your screen. Your feedback really is helpful. We think about it every time. We consider it every time as we plan future webinars like this one. I hope you'll join us for our next webinar focused on winter weather. If you are interested in checking out past webinars and to find information about future webinars, visit our website, www.noaa.gov/central region, where you will also find more great information. Thanks again for your participation and have a fine day.